Hello my dear class 7ers. Now today we will discuss with a new portion of the same chapter, sound. So in the last class I have explained you about the definition of sound, how the sound is produced and the sound from a different musical instrument. Now today we will discuss with the sound waves. Now as you know that sound travels in the form of waves. Waves means like this. Okay, sound travels in the form of waves and it reaches to your ear and our ear will be able to communicate. Now, sound is an example of a wave motion. It is an example of a wave motion. Now, when we discuss about the wave motion, since sound is an example of a wave motion, there are a few terms which you should know. Number one point is oscillation, second one is the wavelength, third one is the amplitude, fourth one is the time period, and fifth one is the frequency. So these things you should know when we discuss about the sound in the form of waves. Okay, and this sound is a continuous disturbance of the medium. There is a continuous disturbance of the medium. So now this is the diagram of a sound wave. Okay, this is the graphical presentation. We will say the graphical presentation of a sound waves. Now this line, this vertical line represents y-axis and this horizontal line represents x-axis. Okay, so how you know is that if I draw a line like this, okay, this is y, o, y dash, this is x, o, x dash. So that means horizontal line is the x-axis, we call it, and the vertical line is the y-axis. So I have drawn here x-axis as well as the y-axis. Okay. So on this axis, on the x-axis, I have drawn a curve. Okay, this type of curve I have drawn here, and I have written here A, B, C, D, E. Okay, then N, M. Okay, then O, P. Okay, then NQ. Okay, so these are the alphabets I have written here. Now first one, we will discuss about the term oscillation. Oscillation is the to and fro. To and fro means the forward and the backward. Okay, forward as well as backward. The to and fro motion of the particle is known as oscillation. The to and fro motion of a particle from the mean position. From the mean position means from the position of the rest. Mean position means the rest position. So therefore, oscillation is the to and fro motion of a particle from the mean position is known as oscillation. So that means from this diagram, which one represents the oscillation? One oscillation is AC represents one oscillation. That means now this line, you can see this curve here. Now this upper part of the curve is known as a crest. This one is known as the crest, C-R-E-S-T, crest, and the lower one is known as the trough, T-R-O-U-G-S, trough. Okay, so what happens that one crest, okay, this is the mean position, starting position, one crest and one trough. Okay, and one trough ends at C. And starting from A is the mean position, C is the position where it has stopped. So that means now this A and C makes one oscillation. A and C, AC makes one oscillation. Similarly, C to E makes another oscillation here. Okay, so that means two oscillations are there. So oscillation means the to and fro motion of the particles is known as oscillation. So in this diagram, in this graphical presentation of a wave motion, AC represents one oscillation. Again, CE represents another one oscillation. Okay, so from the definition of oscillation, we can find that A is the mean position and C is the final position, and one crest and one trough. The point where one crest and one trough is there, so that makes one oscillation. Okay, so that one is oscillation. So AC represents oscillation. Next one is the wavelength. Wavelength means the length of one wave in x-axis. X-axis means this one. The length of one wave. The length of one wave means when they make one wave, the length of one wave means from A to C. That means from A, starting from here. N and Q represents one wavelength. Is it clear? N, Q represents one wavelength. So that means one wavelength means one crest, one trough and one crest. So that means this length represents one wavelength. And this wavelength is derived from the Greek word or Greek letter known as lambda. It is known as lambda. L-A-M-B-D-A, lambda, which is symbolically written as, it looks like pi. Okay, it looks like this one. You write one long line here and another line you just cross it here. So this is lambda. So wavelength. So wavelength is and Q represents one wavelength. Okay. Similarly, AC, that means AC represents another wavelength. So that means this part, look at it. This represents and Q represents one wavelength. Similarly, AC represents another wavelength. Okay, so these are all the wavelengths. So next one comes the amplitude. Amplitude means the maximum distance covered by the wave is known as amplitude. The maximum distance or the displacement. Okay, the maximum displacement means n is the amplitude here. Okay, so this is the maximum displacement. So as long as this crest will, if this crest can go more. Okay, it can increase and this trough can also be increased. Okay, so more the crest will increase, more will be the amplitude. More the trough will be increased, more will be the amplitude. So that means I can do like this. So that means this will form from this region. Okay, will form as a amplitude. Again, another region is also formed as this amplitude. So that means N, M, and OP are the amplitude of a wave. Okay. Now next one comes the time period. The time taken by the wave, time period means the time taken by the wave to make the time taken by the wave to make one complete oscillation. Time taken by the wave to make one complete oscillation is known as time period. So that means oscillation means from A to C to make one oscillation. Okay, from one crest and one trough to make this oscillation. The whatever time is required, that is known as the time period. So time period is the time taken by the wave motion to make one complete oscillation is known as the time period and is symbol as capital letter T. Time period is symbol as T. Then next one comes the frequency. Frequency means the number of oscillation. Number of oscillation means how many times the wave will oscillate to and fro. The number of oscillation made by the wave motion in 1 second. In 1 second, how many oscillation it can make? Look at here. So from A to C, one oscillation. From C to E, another oscillation. Okay. So that means this oscillation goes on increasing. Okay. So but how many oscillation we make in 1 second? That we call it as a frequency. So frequency is the number of oscillation made by the wave motion in 1 second is known as the frequency. Okay, and there is a relation between the time period and the frequency. So the time period is equals to 1 by f, and the frequency is denoted by small letter f. Okay, frequency is denoted by small letter f. Time period is denoted by capital letter T. Similarly, wavelength is represented as lambda. Okay, which is derived from the Greek word. So time period equals to 1 by f. 1 by f means 1 upon frequency. Okay. And this time period is 1 upon f means it is inversely proportional to the frequency. Okay, inversely proportional. Inversely proportional means they are not related. They are not directly related with each other. Which means if the frequency is more, time period will be less. If the frequency will be less, time period will be more. If the frequency will be more, time period will be less. That means they are inversely proportional. So there is a relation with the time period and the frequency. T is equals to 1 by f. And the SI unit of frequency is taken as hertz. TZ. The SI unit of frequency is hertz, and in a short form it is written as Hz. Okay, so these are the terms related with the sound waves. When the sound travels in the air, and always the sound needs a medium to travel. Medium is air. Okay, and the sound will not travel in a vacuum. So sound always need a metal medium to travel. And metal medium means the air is needed. If there is no air, okay, you won't be able to hear the sound, because the sound always it has to travel in air in the form of wave, and therefore we can say that sound is an example of a wave motion. So these are the terms you should remember when we discuss about the sound as a wave